Hi students, good morning. Exercise 9.1. Use the graph to find the limits. If the limit does not exist, explain why. Okay, question number 7. Limit x approaches to 3, the function 4 minus x. Okay, this is the graph here. X approaches 3. X approaches 3. Okay. X approaches 3. Okay, we check into these points. Okay, we check into these points. Okay, here the limit exists or does not exist. How to identify the given functions have the limit or does not exist. Okay, we have 3 stages. In the first stages, the first one is limit x approaches 3, the function 4 minus x. Okay, 4 minus x. Here, substitute x equal to 3, 4 minus 3, which is equal to 1. It means x approaches 3, f of x approaches 1. It means y approaches the value 1. Okay. Then the second one, limit x approaches 3 plus, okay, 3 plus, it means x approaches 3 from the right side, okay, from right side, that is 4 minus x here. Then the function 4 minus x, substitute 3, 4 minus 3, which is equal to 1, okay, if exists. In the third one, limit x tends to 3 minus, here 3 minus means x approaches 3 from the left side, okay, from the left side. Here don't consider x equal to minus 3, okay, which is wrong. Here x equal to 3, the power, the sign represent approaches to 3 from left side, okay, from left side. Okay, here the function 4 minus x, okay, 4 minus x, which is equal to 4 minus x is 3, which is equal to 1. Okay, here these values are equal. In same time, unique number, okay, unique real number. Therefore, the given function limits exists. Okay, limit x tends to 3, f of x, which is equal to limit x tends to 3 plus f of x, which is equal to limit x tends to 3 minus f of x. Okay, these are equal. Therefore, the given function have the limits. Okay, that is, therefore limit x tends to 3, 4 minus x, which is equal to 1. Okay, which is equal to 1. Limits exists. Suppose if above 3 conditions is not satisfied in any one conditions is not satisfied, mean the given function does not exist. Okay, the limits are does not exist. Okay, next 8th question, limit x tends to 1, it is x approaches to 1, the function x square plus 2. This is the given graph. Okay, here the functions have limit it is if it exists or does not exist. Okay, at 1, at x equal to 1. Now check it in the first one here, limits exists or does not exist. How to identify? In the first one, limit x approaches 1, function x square plus 2, which is equal to, here x equal to 1 square plus 2, 1 square is 1 plus 2 is 3. Okay, in the second one, limit x approaches 1, plus means x approaches 1 from the right side, okay, from the right side, from the right side, okay. Here x equal to 1 means x equal to 1 means, okay, here x square plus 2 which is equal to here x square 1 square plus 2, 1 square 1 plus 2 is 3, okay. The third one limit x approaches 1 minus, it means x approaches 1 from the left side, okay, from the left side. Here the function is x square plus 2. Substitute x equal to 1 square plus 2 which is equal to 3. Therefore the values are same, okay. That is unique real number. Limit x approaches 1 f of x which is equal to limit x approaches 1 plus f of x which is equal to limit x approaches 1 minus f of x. All are the values are equal. Therefore the unique values, that is given functions limit x approaches 1 function x squared plus 3, sorry, x squared plus 2, x squared plus 2 which is equal to 3, okay. Limits exits. Question number 9, limit x approaches to f of x, where f of x equal to x not equal to 2 means we take the function 4 minus x. Suppose x equal to 2 means we take the function 0. This is the given graph. In the given graph have one hollow circle, isn't it? Hollow circle at x equal to 2, okay, at x equal to 2. At x equal to 2 have one hollow circle. Here solution, the first one limit x approaches 2, okay, f of x. X approaches 2 means x equal to 2, okay. In particular stage x approaches 2 and next stage x equal to 2, okay. That is we take the function 0, we take the function 0, okay. Then the second one limit x approaches 2 plus, okay, 2 plus, it means x approaches 2 from the right side, okay, from the right side, but not x equal to 2, okay. It means we take the function 4 minus x, okay, 4 minus x, okay, 4 minus x. That is limit x tends to 2 plus the function is 4 minus x. Here substitute x equal to 2, that is 4 minus 2 which is equal to 2, okay. The third one limit x approaches 2 minus f of x. It means x approaches 2 from left side, okay, from left side. So we choose the function 4 minus x. Limit x tends to 2 minus we choose the function 4 minus x. Now substitute x equal to 2 into here, that is 4 minus 2 which is equal to 2, okay. Here limit x approaches 2 plus, that is f of x which is equal to limit x approaches 2 minus f of x. Both are equal but not equal to limit x tends to 2 f of x, okay, f of x. It means limit does not exist when x equal to minus 2, okay. In the first one, this is the important one. When x equal to x equal to 2 means, okay, x equal to 2 means, then the function does not exist, okay, does not exist. Suppose if x approaches x approaches 2 means the function have the limit to function have limit is 2, okay, limit is 2. X equal to 2 means the function does not exist. Suppose x approaches 2, either side means from left side and from right side, okay, both either sides function have limit is 2. Question number 10, limit x approaches 1 f of x, where f of x equal to x not equal to 1 means we take the function x square plus 2. Suppose x equal to 1 means we take the constant function 1, okay. This is the given figure, okay. X approaches 1 in the graph have one hollow circle. In same time x equal to 1 approaches the spherical circle, that is the value x approaches 1, the function that is y approaches the value is 1, okay, y approaches value is 1, okay. Here the first one, limit x approaches 1, okay, x approaches 1 f of x, which is equal to we take the function x equal to 1 means constant function, that is limit x approaches 1, the constant function is 1, which is equal to 1, okay. In the second one, limit x approaches 1 plus f of x. 1 plus means x approaches 1 from the right side, okay, from the right side. So we take the function x square plus 2, okay. Limit x approaches 1 plus we take the function x square plus 2. Here substitute x equal to 1. 1 square is 1 plus 2. 1 plus 2 is 3. Okay. In the third one, limit x approaches 1 minus f of x. It means x approaches 1 from the left side. Okay, from the left side. We choose the function x square plus 2. Limit x approaches 1 minus we choose the function x square plus 2. Here substitute x equal to 1 into here. 1 square is 1. 1 plus 2 is 3. 1 plus 2 which is equal to 3. Here we conclude one result. Limit x approaches 1 plus f of x which is equal to limit x approaches 1 minus f of x which is not equal to limit x approaches 1 f of x. Okay, therefore if x approaches if x approaches 1, then the function, that is then function f of x approaches the value is 3. X approaches 3. Therefore limit is 3. Okay, limit is 3. Limit is 3. In another one case, if x equal to 1 means, then the function then function does not exist. Okay, does not, then the functions of limits does not exist. Okay, next question number 11. Limit x approaches 3, given function 1 divided by x minus 3. This is the figure. Okay, here the first one, limit x approaches 3, the function 1 divided by x minus 3. Here substitute x equal to 3, 1 divided by 3 minus 3, 1 divided by 0, anything by 0, that is infinity. Therefore the given function is not defined. Therefore given function is not defined at x equal to 3. Okay, at x equal to 3. Now we check the functions have the limit either side. Okay, either side means right side and left side. Okay, in the second one limit x approaches 3 plus, then the function 1 divided by x minus 3. Okay, x minus 3 is equal to, refer the figure, x approaches 3 plus means from the right side. Okay, from the right side the curve is upward. Upward means goes to plus infinity, isn't it? Goes to a particular stage, goes to plus infinity, that is plus infinity. Okay, in the third one, limit x approaches 3 sin minus 1 divided by x minus 3, which is equal to, here refer the figure, x approaches 3 from left side, the curve is downward, isn't it? The curve is downward in particular stage which goes to infinity, isn't it? Yes, that is minus infinity. Here limit x approaches 3 plus f of x, which is not equal to limit x approaches 3 minus f of x. Both are different values. Okay, both are different values, that is distinct values. Therefore the given functions does not exist. Okay, does not exist. Given functions of limits does not exist. Therefore limit x approaches 3 f of x of limits does not exist. Okay, does not exist. Question number 12. Limit x approaches 5, absolute value function x minus 5 divided by the factor x minus 5. This is the given figure. Okay, here absolute value function, this is rough work. Yeah, rough work. Modulus of x, which is equal to the function which can be written as plus x minus x. Plus x means x greater than 0, minus x means x less than 0. Okay, similarly in our problems, absolute value function in the factor x minus 5, which is equal to, here x minus 5, this is plus means x greater than 5. Okay, x greater than 5, this is the factor. X minus 5 which is equal to 0 means x equal to 5, that is x greater than 5, we choose plus x minus 5. Suppose minus x minus 5 means x less than 5. Okay, x less than 5. Okay, here in the first one limit x approaches 5 plus, okay, x approaches 5 plus, then the function, absolute value function, x minus 5 divided by x minus 5, this is the factor x minus 5. Here plus 5 means x approaches 5 from the right side, okay, from the right side, okay, from the right side. From the right side means we choose a factor limit x approaches 5 plus, we choose a factor plus x minus 5 divided by x minus 5, okay. Here x minus 5 are cancelled, then the final result is plus 1, okay. That is limit x approaches 5 plus 1, which is equal to 1, which is equal to 1. In the second one, limit x approaches 5 minus, okay, it means x approaches 5 from the left side, okay, from the left side. From the left side means we choose a factor that is absolute value function divided by then the factor x minus 5, which is equal to limit x approaches 5 minus, that is choose a factor minus x minus 5 divided by x minus 5, okay. Here x minus 5 are cancelled, then the finally we get limit x approaches 5 minus 1, which is equal to minus 1, okay. Here limit x approaches 5 plus f of x, that is the function, given function, which is not equal to limit x approaches 5 minus f of x. Therefore given function of limit does not exist, okay, does not exist. Question number 13, limit x approaches 1 sin pi x. This is the given graph, okay. We check x approaches 1, okay, we check this point, okay, we check this point. Here in the first one, limit x approaches 1, the function sin pi x, okay, pi x, substitute x equal to 1 into here, that is sin 1 pi, okay, sin 1 pi. Sin, the value of sin pi is 0, okay, and the value of sin pi is 0. In the second one, limit x approaches 1 plus sin of pi x, okay, sin of pi x. Here x approaches 1 plus, this is 1, x approaches 1 plus means from the right side, okay, from the right side, the graph, in the entire graph, don't break in any point, don't break at any points. Therefore the given graph have the limits, okay. Now to find limit x approaches 1 plus sin pi x, which is equal to sin pi into x approaches 1 means 1 pi, okay, 1 pi is pi, okay, sin pi, value of sin pi is 0. In the third one, limit x approaches 1 minus sin pi x, okay, sin pi x, which is equal to x approaches 1 minus means from the left side, okay, from the left side, that is sin x equal to 1 means 1 into pi, that is sin pi, the value of sin pi is 0. Therefore the values are equal. For limit x approaches 1 f of x, which is equal to limit x approaches 1 plus f of x, which is equal to limit x approaches 1 minus f of x. all are equal, that is unique real number. Unique real number is 0. Therefore, the given function limits exits. Given function limits is exits. That is limit x approaches 1 sin pi x equal to 0. Question number 14. Limit x approaches 0, then the function secant x. This is the given graph. Okay, we check x approaches 0. The function have limits exits or does not exits. Okay, in the first one here we check x approaches 0, doesn't break the curve. So in our assumption the function have limits. Okay, we check it. In the first one, limit x approaches 0, then the function secant x. Okay, secant x. Here x equal to 0 means secant 0. Secant 0 is 1 by cos 0, isn't it? 1 by cos 0. 1 divided by cos 0. Cos 0 is 1. 1 by 1. 1 divided by 1, which is equal to 1. Okay. In the second one, limit x approaches 0 plus secant x. 0 plus secant x. X approaches 0 plus means from the right side. Okay, from the right side. That is secant x is 0. Secant 0 can be written as 1 divided by cos 0. Cos 0, value of cos 0 is 1. That is 1 divided by 1, which is equal to 1. In the third subdivision, limit x approaches 0 minus secant x. It means x approaches 0 from the left side. Okay, from the left side. Here the function secant x approaches 0 means substitute x equal to 0. Secant 0 is can be written as 1 by cos 0. 1 by cos 0. The value of cos 0 is 1. That is 1 divided by 1, which is equal to 1. Here the value all are same. Okay, therefore limit x approaches 0 f of x, which is equal to limit x approaches 0 plus f of x, which is equal to limit x approaches 0 minus f of x. All are equal, that is unique real number is 1. Therefore given function have limits. Therefore given function of limit is exits. Therefore limit x approaches 0, then the function secant x, which is equal to 1. Okay, which is equal to 1. Suppose they are asking in the same figure x approaches by 2 means. Okay, assume that x approaches by 2 means the curve break up. Okay, the curve break up at x equal to by 2. Therefore the given function does not exit. Okay, at x equal to pi by 2. Suppose in another one, creative, x limit x approaches minus by 2 means. Okay, minus by 2 means the curve break up at x equal to minus by 2. Okay, therefore have left limit and right limit have distinct value, that is different value. So the given function doesn't limits or does not exit at x equal to minus by b2. Okay, they are asking in our problem x approaches 0 means right limit left limit are the same value, that is unique value. Therefore the given function have limit at x equal to 0. Okay, question number 15, limit x approaches by b2 given function tan x. This is the given curve. Okay, given curve, the given function tan x, we will check the function have limit if it exits or does not exist at particular point x equal to by b2, x equal to by b2. Okay, right approaches have some value, left approaches have different value. Therefore the given function does not limits does not exit at x equal to pi b2. Okay, the written in the statements. Suppose in the questions asking x approaches pi means right approaches and left approaches are have the same value, same unique value. Okay, same unique value is 0. Therefore the given function limit exits. Okay, limit exits at x equal to pi. In our problem they are asking x approaches pi by 2 means the function of limit does not exist. Okay, in the statement, the first one, limit x approaches pi by 2 plus means from the right side the function tan x. Okay, tan x pi by 2 plus means right approaches. Okay, right approaches, the curve is downward, at particular stage reach minus infinity. Okay, at particular stage reach minus infinity, that is tan of pi by 2 is equal to minus infinity. Okay, the second one, limit x approaches pi by 2 minus means tan x, which is equal to minus means x approaches by 2 from the left side means the curve is upward at particular stage reached plus infinity. Okay, that is tan of pi by 2 which is equal to plus infinity. Refer to the figure. Okay, refer to the figure. Therefore limit x approaches pi by 2 plus f of x is not equal to limit x approaches pi by 2 minus f of x. Therefore given function of limit is does not exist. Okay, does not exists. Okay, thank you.